Hi, I'm going to tell you about the FishMet model. It's a process simulation model, and it's quite different from the AI models based on artificial intelligence because it integrates biological knowledge about how about the fish gastrointestinal system. Our model, this is an outline of the FishMet. It looks a little bit complicated, but it's not very complex model. It starts from the decision of the fish to eat or not eat a single food item. Then if the fish eats the item, just a pellet in most cases, it goes through the gastrointestinal system, it goes to stomach, then to gut, then there is absorption, and then evacuation of the excrements. And the model also implements our knowledge about the neuroendocrine pathway that control the appetite. So appetite is controlled by the distension of the stomach, the amount of food in the midgut, the amount of energy available in the fish, the speed of energy incoming, and then energy balance. And also energy, of course, depends on the activity. And so all these many feedbacks are implemented in the model. I'm going to show any formulas and so on, so just this outline. So the idea of the model is that we can represent a fish as a computer game. But there is no body, of course, this is only the gastrointestinal system. So we can very different feeding protocols, different regimes, and so on. And as a result, we get the output of fish behavior, feeding behavior, activity, energetics, growth, and so on. The main use of the model is to do a kind of predictive analytics and what-if scenario modeling. Like if it decide to change the scheduling, what will be the result from a part of the fish? How it will respond to this change? How the growth will change? How behavior can change, and so on? What are the energetics? And the model is implementing a computer program. It has command line interface shown as screenshot here that can be used to do different scenarios. There is scripting language implemented in this model and can be used on a server or on the desktop and so on. And it's also, the model is also platform independent. It can be compiled on Windows and on Linux. There is also a graphical user interface shown here. So it's possible to do simple experiments in this point and click interface. And I will show you the input of the model. There are quite many parameters describing the fish physiology, but in most cases they are just fixed depending on the fish species. The current model is made for the Atlantic salmon, but it's quite generic. By defining and redefining the parameters, different fields can be modeled. And in the simplest case, what we need as input is the characteristics of the feed, like the mass of the single pellet, temperature, the body mass of the fish, and the food input rate. And also the input is a food scheduling. It can be very detailed by, for example, by 1 second. Either food is coming or not coming, and what is the rate. And the output of the model is we can get quite a lot of outputs because we can save all the dynamics, like the amount, the stomach fullness, gut fullness, and so on, energetics. There are just a couple of screenshots. And the global output is, of course, the fish mass, the fish growth rate, and so on. energy balance, food conversion rate can be calculated easily, and so it can be used as a research tool and also as an applied tool. Here is just an example of another experiment, the computational experiment. It shows 1 week of fish feeding with 2 meals daily. It's the number of food pellets eaten by the fish. And this is stomach fullness. You see that there are 2 peaks on the stomach fullness. And this is the instantaneous growth of the fish. And so very detailed scenarios can be modeled. And there are no basic limitation on the food schedule. Anything can be modeled, can be used as input. We also have implemented a server components that can be used to run the model on a server. And these server-based components are integrated into the iBoss. So iBoss can send requests to the FishMet server. FishMet server do some calculations and send back data to iBoss. There is a website integrated with the FishMet server, and the description of the model can be found on this website. It's fishmetuid.no. And finally, I don't think it's very interesting, but it shows this diagram shows the details of interaction between iBoss and FishMet. All the interactions are initiated by the iBoss on demand, anytime. iBoss sends the input data for modeling, basic parameters, and food schedule. Server components do some translations, run simulation, and send back data to the iBoss. And iBoss get this data, integrates into the predictive analytics. This is how it works. I try to be brief. Thank you for your attention.